Okay, the first experiment using LT spice simulation experiment is voltage multiplier. In that in that voltage multiplier, so you'll be doing voltage doubler circuit. So in voltage doubler there are two types. So one is called full wave voltage doubler, so another is half wave voltage doubler. So this circuit is half wave voltage doubler. So let us see why it is called half wave voltage doubler through its working principle. So this is voltage doubler means the output voltage of this circuit, which is a DC, is equal to 2 times peak of the input signal. So if this is an input signal, the output voltage will be, which is a DC voltage, will be approximately 2 times the Vm. So that's why the name it is voltage doubler circuit. So let us see how this circuit works. So you should start analyzing the circuit from that part of the input cycle which will forward bias the first diode. So that means during first negative off cycle, so this end is positive, this end is negative, diode D1 is forward biased, D2 is reverse biased, and the capacitor C1 charges in this direction. To the net voltage in the circuit, the maximum voltage in the circuit is Vm of the input voltage. So capacitor voltage will charge to plus Vm in this direction. So this is plus and this is minus. This is during first negative off cycle. Now during next off cycle, that is positive off, this end is at higher potential compared to this. So this end is okay. Will be higher potential compared to this end. So now what happens is diode D1 is reverse biased, D2 is forward biased, and the capacitor C2 charges to the net voltage in the circuit, which is Vm from the input plus another Vm from the capacitor C1. So totally output voltage will be 2 times Vm. That's why the name voltage doubler. And why it is called half wave voltage doubler is the output capacitor C2 is going to be charged only during one half of the input cycle. So in this example, during the positive off cycle. So we will assume that the RC time constant, this RC time constant is very high, so that the capacitor will not discharge quickly. So based on that, the design of this circuit is made. The RC time constant should be much greater than time period of the input signal. Let us take RC is equal to 100 times T, which is much larger than T. And if you assume frequency is equal to 1 kilohertz, then T is 1 millisecond. And if I assume C is equal to 1 microfarad, R value will be 100 kilo ohms. So this is the design and working of voltage doubler. Now you have to simulate this circuit using LT spice. Now I'll open the LT spice. First install LT spice on your desktop and or laptop. And double click on the icon LT spice. Okay. It is asking me to you want to update the software. I'll say no. So let it be So you'll get a window like this. Now first create a new schematic. So this is a new schematic, that is new file, and save this file with a proper name. So since this is a new schematic on voltage multiplier, let me save this as a file name in my directory itself. So better you save it in a particular directory. Otherwise it will be saved in a default directory. So I'll give proper name for this. So I'll give the name as VM. So voltage multiplier. So save this. Now I have to rig up the circuit here. To rig up the circuit, you require some components. So the components can be drawn using this component icon here. So when you move the mouse close to this icon here, sorry. So I'll get the label component there. So if you click on this, so you'll get list of components. You can select from this, or when you go to edit, so I'll get component like this, or already some default components are there: capacitor, inductor, diode, resistors, so which are also available here also. So you can see there are some components already available here. So diode, inductor, capacitor, resistor, you can use default components which are already there in the menu, or you can draw the components. So let me use the component which are already available here. So I want to rig up the circuit. I want two diodes, two capacitors, and one resistor. So edit, I'll go to component. So like this also you can draw. So there is a resistor, or if you click, so you'll get a resistor. So it is going to a different directory. So you have to choose the proper directory and you can select the components. So you can go one level up and you can see here there are so many components: NPN transistor, PMOS transistor, NMOS transistor, NPN, PNP transistors. So there are similarly LEDs, inductors. Similarly, you can search for what components you want, diode, or else you can draw it from the list here. So the list is, the register is here, capacitor, diode. So I want diode now. I'll click on this diode. I'll get a diode. This I want to reverse the polarity. Before you place by clicking, use Ctrl R. Press Ctrl R. It will rotate. I want once again press Ctrl R and place it on the screen. Now I want one more diode. Direction you change by pressing Ctrl R and place it here. So then press Escape or right click on the mouse to cancel the next placing. So I'll press Escape. So that selected item is gone. So I want two capacitors. Capacitor 1. So I'll change the direction. So plus and minus. Sorry, horizontally I want to keep the capacitor. Here also I want to keep the capacitor vertically. Use Ctrl R. So place it in appropriate place now. Now diodes and capacitor are placed. If you want to once again move this, use this and symbol here, which is move. Click on this capacitor, and wherever you want you can move. Click and it will be placed. I need one resistor. So select this resistor and place it here at the output side. I need one ground. So this is ground. Select this and place it here. I need a voltage source. So voltage source, there is no voltage source in the menu icon there. So I have to get it from the component list. So go to component and select a voltage source. So I'll go to edit, component. So in the, you can see here voltage. So select this voltage source and place it at the left side. So then you have to connect all of them using wires. So let me use wires now. This is wire. Click on this and connect these components. Click once, and once again if you click, this capacitor will be connected to diode. Similarly, you do the remaining connection. So you do the only connection. So deliberately I'll do mistake here in the connection, and I'll show what is that later. So now connection is over, and you can see wherever there is a node you can get this dot. So this is a node where three or more branches meet. So this is a node, and this is also a node. But here this is not a node. Still you got this because you connected some extra wire. You can remove that extra wire using this cutter. So you select this cutter, click on this, so that extra wire is removed. Now you have to give the values of resistor and capacitor according to the design. When you move the mouse close to this capacitor, you'll get a hand symbol. Right click on this, you'll get capacitance, or the C value which is there. Right click on that, that you can change. So the value of the capacitor, earlier it was C, can be replaced by some value now. So I will give some 1 microfarad. So here it is 1 U. Micro is by U. So it is 1 U. So 1 microfarad. Similarly here also this capacitor also 1 microfarad, 1 U. So 1 microfarad and 1 microfarad. Now let the diode be default diodes. I will not change any parameter of the diode. Resistor I will make it 100K according to the design. Automatically take ohm. So 100K is enough. 100 kilo ohms, 1 microfarad, 1 microfarad. Then voltage source, I want to make it as a AC voltage source, that to sinusoidal voltage source. So move the cursor close to this voltage source, we'll get a hand symbol. Then right click on that. And if you want this to be a DC voltage source, then the value of the DC voltage you can type here and click OK. But you want this voltage source to be other than DC, then you have to go to advanced. Go to advanced, and here you select sine wave. In this sine wave, once you click on the sine wave, you'll get options here like DC offset, amplitude, frequency, like that, out of which you give only amplitude and frequency. So frequency, let me give 1 kilohertz, amplitude 5 volts, and how many cycles you want to see, After simulation, that you can write here, I want to see 10 cycles of the sine wave. So I'll write n is equal to 10 and click on this OK. So an assembly, or sorry, spice directive is written. So click on this and you can place it anywhere here. So this is one spice directive based on a voltage source setting. So 5 volts, 1 kilohertz and 10 cycles you can see. Now you can add label. This is important. If without label, later on you can't see where is the readings you are taking, which current reading or which voltage readings you are observing. So better you use labels here. So I'll click on this label and I'll get a text window to type the name for the label. So I've written VI and the type of this port is input. Select input and click OK. Place it here and let me place one more here. But I'll rename this as, right click on to rename. Rename it as V0 output voltage and this will be output port. So now this is the output port. Now connect this to the point. So this is input point and this is the output point. So connect this. Now labels are ready. Voltage source is set. Then what to do? So here I want to see input waveform and output. So that means your waveform voltages versus time. X-axis is time. To run this or to simulate this circuit, the circuit is already ready. So I want to simulate this. But what you want to do for that, first save this file, then go to simulate, simulate menu and click on edit simulation command. If you click on this edit simulation command, you'll get a window here. So when you see this window, there are multiple options. So one is transient, so another is AC analysis, so another is DC sweep. So whenever your x-axis is time, it has to be transient analysis. Whenever x-axis is frequency, it has to be AC analysis. Whenever x-axis is some DC voltage like VDS, in case of MOSFET you have seen, drain to source voltage is your x-axis, drain current is your y-axis. In that case it has to be DC sweep. So once again I'll repeat, when the x-axis of the waveform is time, then it is transient analysis. If the x-axis is frequency, then it is AC analysis. If it is x-axis is a DC voltage, then it is a DC sweep. Now since we want waveform with, that is voltage with respect to time waveform, then you have to select the transient. So that tab is selected now and here you can fill up this data like what is the stop time, after what time your simulation should stop. Since I want to see 10 cycles and frequency of the input signal is 1 kilohertz, time period of the each cycle is 1 millisecond. So 10 cycles means 10 milliseconds. So I'll write 10 milli. By default it will take seconds. So I want this simulation to be done for 10 milliseconds. So click on this OK. You'll get a spice directive, place it on the screen. Dot trans 10 millisecond. So transient analysis for 10 millisecond. So that is the command. So save now. After saving, now you have to run this. So all these things are set right now. So there is an icon here, run. So you can see the symbol here. So you click on this run. This run. Click on this run. Now you can see here we'll get a graph here whose x-axis you can see it is time. The x-axis of the graph it is time. So 1 millisecond, 2, 3, like that it is 10 milliseconds. So simulation is done up to 10 millisecond. So x-axis is time now. Now what you have to do? So I want to plot input waveform and output waveform. Move the cursor close to this Vi. You can see there is a one probe. You can see one probe coming. So you can move the mouse close to this. You can see that red color probe. You can observe that is called voltage probe. And if you move the mouse close to the device here, you'll get a ammeter. So this whenever you want to measure current, I'll click on this now. So this will show you the current through this device. See, this is current through the capacitor. This is the current through this diode. Similarly, current through this. If you want to see the voltage, then you should get this probe. Now I will want Vi. Click on this. I got this input voltage waveform, and I want output voltage. Click on this. And if you want to change the color of that graph, go to this. You'll get a hand. So on the top, you can see here Vi, and this is V0. So move your mouse close to this, you'll get a hand. Right click on this. Here you can change the color of that. So let me change the color to red so that it is visible. So now output capacitor is charged like this. This is how it will charge. Even though ideally we'll say in one cycle it will happen, it will not happen in one cycle. It will take its own time to charge to the maximum value. Now I want to know what is the maximum value of this output voltage. After some time it becomes a constant DC. To know that, move the cursor close to this V0, you'll get a hand symbol. Just click on this. If you click on this, you'll get a cursor. So this cursor, if I move like this, it will move along the output. And you can see this is the value of x-axis and this is the value of y-axis. Since I want the maximum output voltage, I'll move the cursor to the rightmost side, and now this is around some 10 millisecond, close to 10 millisecond, and the output voltage is 8.56 something, close to 8.6 volts. But I want 2 times Vm, that is 10 volts, but 1.4 volts is lost in these diodes. The diode is having a cut-in voltage of V gamma each. So 1 V gamma for one diode, another V gamma for another diode is lost. So output voltage practically will be 2 Vm minus 2 V gamma. So output voltage will be not be 2 Vm actually, it will be 2 Vm minus 2 times V gamma. So if V gamma, if it is 0.7, it will be 1.4 is already lost in this diode. So and this diode may be having the forward resistance. Some small voltage drop also will be there in that. So your output voltage will be close to 2 Vm minus 2 V gamma, maybe a bit less than that. Now I want to, so the advantage of going for simulation is I can change the parameter of any devices here, values of these devices, and I can simulate within few seconds. I can change the values and check and test what happens. I can experiment easily. Whereas in case of rig up experiment, it is very difficult. So I'll now change some parameter and we'll see what happens. So now what I will do is this RC time constant will reduce a bit. So this R which was 100K, now I'll make it 10K or 1K itself. Let us see if I make it 1K, what will happen. I want RC should be much greater than T. Now this is not satisfied. Let us see whether the output voltage is doubled. So save and run this now. When you save this and run and place the mouse close to VI, I'll get VI now. Then V0, change the colors so that you can see that. Now you can see the output is not twice the input peak. It is almost input peak. It is not charging to 2 times Vm. It is discharging quickly. The capacitor is discharging quickly. So what happens is your capacitor will not charge to the 2 times Vm. It is charging only to the Vm. So this is a problem if you don't meet the design criteria. So that you can easily do. Within minute you can check all this information. Now let us see, I want to change the diode parameter. So I want to make this diode an ideal diode with V gamma 0. So let me keep this R value 100K itself. So let me change the parameter of this diode. So for changing parameter, right click on this D. So that D which is there, I'll give some name. So I'll give this name like MUL. Any name you can give. So preferably I'll give multiplier MUL. So this also I'll give MUL. So when you rename them, diode D1 and D2 by MUL and MUL, I can write a spice directive. That means I can write a command to change this parameter. To do that, so there is a icon here called .op. So you can click on this .op to get spice directive. So this is comment, but I want a command which is called spice directive here. Click on the spice directive and write the command here. The command is model model name. So model name what I have given is MUL. Model type. The type of the model is D here. Diode D stands for diode there. So model mul. What is mul means? The name what I have given. Actual name was D within the bracket. Within bracket. Now I will write down whatever the parameters I want. So let me change some parameter like V forward, EFWD. V forward is equal to 0 or 0 volts or 0. I'll write. So if I make V forward is equal to 0, which means that the forward voltage of the diode is 0. So I'm changing this diode parameter. The forward voltage I want it to be 0. Now if I save this and run and move the cursor close to VI and press it, then I'll get VI, V of VI That means voltage at Vi node. That's the advantage of labeling. Otherwise, you'll get N V of N0001. So you'll not be knowing what is N0001. So always it is better to label proper nodes. Then output I'll get. So this is V of V naught. So I'll change this color, and the mouse, the cursor, I'll move it to the extreme right. Now you can see here the output voltage is close to 2 Vm. So Vm was 5 volts and the output voltage is 9.94. It is not actually 10 because RC time constant is not infinity. That is one reason. Another reason is RF, the forward resistance I have not yet made 0. So there may be a small drop across the resistance also, the diode forward resistance. So because of that, you are not getting exactly 10 here. Now if you know, say you may ask me why only forward, what are the other parameters of the diode? You can go to L topic and see what are the other parameters of the diode. So click on this index and type D, capital D. So you'll get all the information regarding diode. Now you can see these are the model parameters of a diode. So the on resistance I can make it 0, off resistance which is high, by default some values are there, you can change them. V forward, the forward voltage, that is V gamma. Similarly reverse breakdown voltage, the reverse breakdown impedance. So many parameters are there. So you can change the parameters and you can see what will be the simulation result. So this is the advantage of going for simulation. So let me now change one more parameter of diode and see what happens. So let me make R on. So after V forward here, I'll write comma R on is equal to 0. On resistance is also I make it made 0. So all the parameters are separated by comma here. So you can mention any number of parameters separated by comma within the bracket. So press OK, then run this. Now see the output voltage now. So I'll click on this to get the output cursor. So when you move extreme right, now we can see the output voltage is very close to 10 compared to the previous. Now it is very close to 10. And if you further, instead of 10 cycle, if I see 20 cycle or 30 cycles, so it will reach 10 nodes. So another reasons for not getting exactly 10 is this RC time constant is 100 times. So if I make it 10,000 times, 100,000 times, then this voltage will improve. This voltage will improve if I increase RC time constant. So all these things you can try and verify. So this completes the first experiment. So where you have analyzed voltage doubler circuit, designed it, rig up using a simulation tool, LT Spice. We observe the input and output waveforms and we change some parameter of the circuit and see what will happen to the, what is its effect on the output voltage.